In this lesson, I will talk about ways to determine if a relation is a function. But before I do that, I'd like to emphasize that in mathematics, functions are used as a tool for communication. And the meaning of functions in the mathematical language is different from the meaning in the English language. Now, there are two ways to determine if a relation is a function. The first one is if we are given a function or a mathematical equation to determine if the relation is a function or not. As an example, if we have y equals x squared plus 2, what we do is to input some values of x and find its corresponding value of y. We can do that on a table of x and y. So we input some values. We can start from negative, say negative 2, negative 1, 0, 1, and then 2. If we put in these values, we find the corresponding values of y. So y will be equal to minus 2 squared plus 2. And that gives us minus 2 squared is 4 plus 2 is 6. So we get here 6. We put in x equals negative 1 squared plus 2. This gives us 3. So we have 3 here. If we put in 0, we have 0 squared plus 2, and that gives us 2. The next is we have y is equal to 1 squared plus 2. That gives us 3. So we have 3, and the last one is y is equal to 2 squared plus 2. This gives us 4 plus 2, and it's equal to 6. So we have 6. We see that all the values, each value in the domain gives us a unique value in the codomain. We have a 1-to-1 mapping or 1-to-1 relation. The relation is a function. A second example number 2, if we are given y cubed minus x equals to 2 to determine if this relation is a function, the first thing we have to do is, using the first approach, is to write this equation in the form that we can find y when we put in x. So as a solution, what we do is y cubed minus x equals 2. This implies that y cubed is equal to 2 plus x. Here we find the cube root of both sides, and we get y equals the cube root of 2 plus x. As usual, we can input some values of x and then compute the corresponding values of y. From this, we see that any value of x that you input here, say x equals a, produce a y value which is unique, and therefore we say that y cubed minus x equals 2 is a function. As a third example number 3, if we have y squared minus x equals 2, to find if this relation is a function or not, what we do is, still using the first approach, we substitute values of x to determine the values of y. Don't forget, the values of x are the values in the domain, and y gives us values in the codomain. So we write y in the form that we can compute values of y easily. So we have this, and we take square root of both sides. Square root of 2 plus x. Now, looking at this, we notice that anytime we take the square root of a number, we get two values. It is either the positive or the negative. So we write y is equal to plus or minus square root of 2 plus x. Therefore, looking at this, we see that we'll get two values. y1 will be equal to plus square root of 2 plus x, and y2 will be equal to minus square root of 2 plus x. So if we put in any value of x, one value of x, we are going to get two values for y. That is y1 and y2. But in the definition of functions, we have said that two pairs should not have the same first element. Two pair of values should not have the same first element. As an example, if we put x equals 1, we get y1 to be equal to plus square root of 3, and y2 will be equal to minus square root of 3. So, in the nutshell, if we look at the pair of values, we have 1 and then square root of plus square root of 3, and the same 1 minus square root of 3. This is a pair of values with the first element having different images or mapping to different elements in the codomain. Let us not forget the values. The first value is in the domain and the second value is in the code. Therefore, y squared minus x equals 2 is not a function. This will be our conclusion, that y squared minus x equals 2 is not a function. The second method, method 2, to determine if a relation is a function is what we call the vertical line test. In this method, what you do is to sketch the graph of whatever relation you are giving. Now, after sketching the graph, you draw vertical lines through the graph. And if the vertical line cuts the graph or the curve at more than 1 point for one x value, then we say that the relation is not a function. But if the vertical line cuts the graph at 1 point, we say that it is a function. Although we have not discussed the sketching of functions, I'll illustrate with examples so that we have a visual view of how we determine that a relation is a function. So for example, if we have a graph and the graph such that our graph is this way. If we draw vertical lines through this graph, and we see that this vertical lines for every x, we have x1, x2, x3, x4, and x5. Every x has a corresponding value, a unique corresponding value. We have here y1, y2. Each one of them has a corresponding value, y3, y4. So we see that this is a function. Example B, if we have a sketch, or we sketch the graph and it is of this form where we have the curve this way, then we can draw our vertical lines through this graph, and we see that at every point on the graph, x1, x2, x3, we can map it to a unique value of y. So this one will give us y3, this will give us y1, and we have y2 there. So we see that every x has a unique value. We can x1, x2, and x3 as the domain, and we have the codomain. We have y1, y2, and y3, where x1 maps to y1, x2 maps to y2, and x3 maps to y. So there is no first element that maps to two elements in the codomain. So this is a one-to-one relation. This is also a function. Now, let's take a third example. Example C. If we sketch the relation and it is of this form, we have our y and our x. When it is of this form, then we can draw our vertical lines through that. Now, we see clearly from this that if we have here as x1 and x2, x1 has a value of y1. It also cuts the curve at y2 and also cuts it 3 times. So x1 has 3 values. x2 has 3 values. It cuts the graph at points greater than 1. So we see that this is not a function. Not a function. The last example will be if we have a graph of this form. If we draw a vertical line through this, we see that the x value has 2 y1 and y2. So we see that this is not a function. The second approach says that once the vertical line cuts the graph at more than 1 point, then we say that this is not a function. These are the 2 approaches to determine whether a relation is a function or not. See you in our next lesson.